did. I did. The numbers that are the names I called out, people were not here. Everyone else. I'll just double check one more time. Got 1, 2, 3, 4, 5, 6 people. 1, 2, 3, 4, 5, 6. Yeah. All right. Let me just stick this inside here so the folks at home can hear me. Okay. So I'm hoping that that you're having a chance to watch some of the videos at home. I am live every day. I wasn't live yesterday because I had a substitute teacher. I had a doctor's appointment in the morning, so I was unable to attend. But aside from yesterday, we've had some videos every day. So one of the things that we're going to do today, and you're going to do this on your own time. We're not going to spend class time doing it, but I do have a survey that I would like you to fill out. It's just sort of checking in on how you're doing. So one of the things about this year is that I've never taught in this fashion before, right? Usually I see all my students every day, or at least if it's every second day, then I would see you every second day or something like that, right? We'd follow a normal schedule. Never before have I had to teach just like a portion of my students at a time. So one of the things I want to really make sure of is that I'm not overwhelming you with like too much work at home, but at the same time that you're still feeling like we're learning every day. So it's going to be a tough balance to find. So I've got a little questionnaire for you to fill out. I'm going to post that on Classroom today, probably around lunch hour. And I'd like you to fill it out. It's anonymous, so I don't feel like if you tell me that there's too much work, then there's going to be repercussions or something like that. Totally anonymous. I really want some honest answers so I can make some adjustments. So by the way, I think that we will get interrupted shortly, probably by one of the principals. Maybe I just saw Mr. Hutchison walk by, so they might be answering some questions about our new case today. But yeah, so if that's the case and you're watching on YouTube, I'm just going to sort of pause the video, but we'll still carry on. Okay, so if I ask you to multiply 6 times 10, I'm very confident that everybody here would be perfectly capable of doing that. But I do want to explore some of the things that happen when we multiply those two numbers together. So let's multiply these two numbers together. So I'm gonna get 6 times 10 is 60. So 6 times 10 is 60. That's obvious, right? We already know that. That's not really what we're doing this for. I already know that 6 times 10 is 60. Let's try to make the prime factorization of 60. Okay, and let's see what happens. Okay, so can anyone tell me some of the factors of 60? Yeah, go ahead. Yeah. And then 2 again. So it's going to be 2 squared times 3 times 5. So 60, that's what 60 is equal to. Okay, so let's go ahead and draw the prime factorization using the colors that we have. So 6, it looks like we've got already some colors assigned to us. So 2 is orange, right? What's green? Yeah, green would be 3. Oh, good morning. Come on in. Okay, awesome. Okay, and then so we've got 2 already. Again, over here is orange, and then what's blue then? 5. Awesome. Okay, so let's go ahead. So it looks like we have 4 prime factors, right? We've got 4 prime factors. So if I were to write 60 out, let me quickly sort of do this. Okay, so here's my circle for 60. Okay, and that's good enough. Okay, so there's 60, and then I'll write the number 60. Okay, so here's 60. So it looks like I've got 2 oranges, right? 2 orange. So I'm just going to do something like this. 2 oranges, right? Because I've got 2 2s. And I've got 1, 3, and 3 is green, so I'll do a 3 there. And then finally, I've got a blue, so the blue is going to be made up like that. Okay, so I've got 2 oranges, 1 green, and 1 blue. Did we have any new prime numbers that weren't in the 2 factors? No. How many factors does 2 have? Or sorry, how many factors does 6 have? How many prime factors that is? 2. And then 10 has 2. So when we multiply these 2 numbers together, we can see that, well, here's our 6 right here, and then here is our 10, right? So when we multiply 2 numbers together, all of those prime factors, they stick around, right? That's all the number is made up of, okay? So let's try calculating the LCM of these 2 numbers and see what we get, okay? So we're not quite at the point where we can necessarily use our prime factorization to calculate the LCM, but I'd still like us to sort of visualize what's happening here. So for the LCM of 6 and 10, I'm going to do it the old-fashioned way. I'm going to say that, let me use a different color here. I'm going to say that, I'm going to say that the LCM, I'm just gonna find all the multiples of 6 that I know about. So I've got 6, 12, 18, 24, 30, 36, 42, etc. Okay. And then the multiples of 10 that I know about are going to be 10, 20, 30, 40, 50, 60, 70, etc. And then I can see that 30 is on both of these lists. So here's a 30, there's a 30. Okay. So the least common multiple, so the common multiple that's the smallest among those would be 30. Okay, be 30. So let's go ahead and write 30 out using the prime climb or the prime factorization. So here's the prime factorization of 30. Okay, so here's a nice little circle for us. And then we've got the number 30. Here's 30. Okay, so let's find all the factors of 30. So 30 is equal to, well, can someone help me out and list all the factors of, all the prime factors of 30? Go ahead. 2, 3, and 5. Are any of those repeated? No. Okay, so we've got exactly 3 prime factors, okay, each used exactly once. So let's go ahead and write some of these down. So 2, I believe, was orange. So here's orange, and let me make that a little bit thicker. Morning, Mr. Hutchison. Yes, absolutely. Yeah. We're just touching base with all the classes at this point, so an administrator as well as our guidance counselor staff. Just to talk a little bit about what happens into and into Thursday. So just so everyone's aware, we did have a student in the middle school test positive for the coronavirus. Just what happens at that point is Manitoba Health gets involved and starts to conduct an investigation. So Manitoba Health identified a class of students, about 13 students, that needed to do what's called self-isolate, and then they also identified a group of teachers and EAs who were in close contact with that student who needed to self-isolate. Then we had a group of about 20 people who needed to self-isolate, and what they do is they ask those people a bunch of questions, they start to get some testing done, and see if they can rule out anyone else. So right now, as their investigation progresses, they are not finding anyone else responsible. Okay? So it seems to be a very isolated incident with this one student. What happened is that the student was infected somewhere outside in the community. Okay? So a parent or somebody contracted the virus in the household, and that student became a sort of close contact with somebody. So they went to testing, and their testing got positive. But they were asymptomatic when they were in school.
Because remember those questions that you're asking when you're coming into school? They didn't exhibit any of those things with the runny nose and the headaches. They had none of them. So what public health is telling us is that if you don't have any of those symptoms, it's okay if you're in school with a mask on, if you're socially distanced, if your hair sanitized, that there's not really a large chance of anybody getting infected, even though the person. So right now, according to National Health, it's like a very isolated incident. It looks like it's only one person in the school, and then they can have to do. You should also be aware that that evening, so Wednesday evening, about 7 o'clock, there was a team of students that came in from the school division. It's a very special, expensive kind of cleaning device with a fogging machine that actually fogs the areas of the school that we're concerned about, and it's a disinfectant chemical that immediately goes into the school's clean. There's not really any worry about this point as far as the virus spreading without the information that we're getting from them. If we're going to contain this, we'll definitely update people. And right now, what we wanted to do is just keep some of the questions that people have. So there is probably some anxiety and some unsure kind of feelings about it. And if there wasn't any questions on the possibility that our guidance department has on all the different. Nobody will report something. So, you can drop in there and tell them the this one, you can do that. If you have questions for myself or Brett, or high school people, we will drop it in. So if you're not comfortable, kind of drop it into CS, send us an email, or you can ask us for Bennett. If you can, relay the questions for us, and we can answer to you. We also have a school psychologist and school social worker that are available to help us with the family, and questions that we can. We're all in this together. We support them, the family. Just a little personal question. Is there any questions? Depends on board.
Thanks, Mr. Hutchison. Not at all. Okay. Yeah. So just sort of expanding on that, if if you're not sure who to ask, and maybe you don't necessarily want to talk to me, you can always ask me about who you can talk to, and maybe get some clarification of who the guidance counselors are, or the social workers, or the psychologists. I'd be happy to relay any kind of information. You're also welcome to talk to me, but just know that I'm not. I don't have any training in psychology or anything like that. I'm also not like an expert on the virus, so I probably can't answer too many questions. But if you want to just chat, I'm more than happy to do that. Anyway, let's continue on with this. We were just looking at the LCM of 6 and 10, right? So we were looking at the least common multiple of 6 and 10, and we determined that the prime factors were 2, 3, and 5, and none of those were repeated. They only had one occurrence each. So let's go ahead and write those ones down. So I've got about 1/3 of that is going to be a 2, and then another third of it is going to be a 3, like that, and then another third of it is going to be a 5. Okay. Any observations about what's different about the 30 and the 60? Mm-hmm. Yeah, the 30 is half of 60, exactly. So 30, in other words, 30 is a factor of 60, right? 30 has to go into 60. Do you think that's always going to be the case with LCMs and the product, or is it just a coincidence this time? Well, we'll think about that for a little while. Okay, let's say that we've got these two numbers, right? How are these two numbers related to the LCM? Can we see any kind of relationship between the prime factors of 6 and 10 and the least common multiple of 6 and 10? So let's take a look at 6, number 6 here. Okay. How many occurrences of the number 2 do we have in 6? Yeah, just 1, right? How many occurrences of 2 do we have in the LCM of 6 and 10? Just 1, right? What about 3? What are the occurrences of 3 and 6? Just once, right? And then 1 here. And then the same thing over here in 10. So we've got 1 occurrence of 2 right there. There's an occurrence of 2. And again, we've got 1 occurrence of 2 here. And finally, we've got 1 occurrence of 5, and therefore 1 occurrence of 5 in the LCM. Okay? So just some observations. Okay, let's take a look at the GCF, greatest common factor. Okay, so the way I like to sort of start off with this is I like to write out all of the factors of 6 that I know about. So I'll start off with 1. 1 is a factor of every number, right? What's the next one? 2, then 3, then 6. All right, okay, great. And then what about 10? So obviously 1, 2, 5, and 10. Awesome. Okay. Do we see any numbers that are in common here? How many numbers do they have in common? Yeah. Yeah. So we've got 2 numbers in common. I've got a 1 and a 1, right? And I've got a 2 and a 2. Which one's bigger? 2. Okay. Yeah, we've done this before, right? Yeah. Okay. So yeah, 2 is going to be the greatest common factor of 6 and 10. So this is going to be 2. Okay. So if we were to just draw out the number for 2, the prime factorization of 2, well, it would be a pretty straightforward one. It would just be the orange circle, right? So that's all there is. That's all there is to this one. So let's go ahead and write out that 2. So here's my 2, and we've got one big orange circle. Okay. So how could we go straight from these two numbers into the GCF? How are these two things related? Yeah. Yeah, they both got exactly 1, 2, and they have nothing else in common, right? The only other part is the green part and the blue part, but those are exclusive to one another, right? That's not common, right? So that's not a common factor. So the greatest common factor is just 2, and that's all we have, okay? So what I thought we could do is we could try it with some slightly more challenging numbers, okay? Numbers that we might not have the prime factorization of, or at least not in the color coded fashion that we do our prime climb chart with. So let's take a look at the LCM and the GCF of 99 and 63. Okay, we've got 99 and 63. So the first thing that I want to do is factor these guys, right? So let's factor 99. So let's it's too big. Let's factor 99. Okay, can anyone give me 2 factors of 99? 3, okay. So I'm thinking 2 factors who multiply together to get 99. Yeah, yeah, 9 and 11, yeah. And are either of those prime? Yeah, 11. So we'll circle 11. Okay, and what about 9? Can we factor 9? Of course we can. 3 and 3, right? We all know that. Okay, so 99 is equal to 3 squared times 11. Right? That's the prime factorization of 99. Okay, let's do the same thing with 63. Okay, let's do 63. Can someone give me 2 factors of 63? Go ahead. 3 and 21. Okay, that one is prime. And then we can factor 21, of course. What do we get? I'm going to do 3 and 7. Super. So 63 is 3 squared times 7. So let's see if we can find the LCM, the least common multiple of 99, and 63 using those prime factors. Okay, so the least common multiple of 99 and 63. Well, if we go through here, I need it to be a multiple of 99, right? That's what I need. I need it to be a multiple of 99. So that means it's got to be a multiple of this, but at the same time, it has to be a multiple of that as well, right? So how many 3s do you think I need? Just 1 3? Okay. Is it possible to have a multiple of 99 that has only 1 3 in it? Yeah, we're going to need 2. We're going to need 2 3s, because if it's going to be a multiple of 99, well, it better have all of the factors of 99 in it too, right? So we'll also need an 11. Okay. Now we want to make sure that we're finding the smallest number possible. So we don't want to add anything that we don't need, right? So we're trying to be kind of picky about what goes in this number, what all the factors in this number. So this number right here, well, this is 99. So this is a multiple of 99. Is this going to be a multiple of 63 though? 99 a multiple of 63? No, definitely not. Definitely not. Okay. So let's see if we can turn this number into a multiple of 63. So if it's going to be a multiple of 63, it's got to have 3 squared in it, and also it has to have 7 in it, right? In order for it to be a multiple of 63. Do we have any of this already? Yeah, what do we have? The 3 squared. What are we missing? The 7. Yeah, there it is. So if we take a look at this number right here, whatever this number is, 3 squared times 11 times 7, okay? So this right here is 99, right? So this number is 99 times 7. Is that a multiple of 99? Yeah, how do you know? Okay, if I have a number x and I multiply it by 3, is that a multiple of x? Yeah, by definition, because I'm multiplying x by 3, right? So my number here that I'm thinking, the number that I'm thinking about right now is 99. 3 squared times 11, that's 99. 99 times 7, is that a multiple of 99? Yes, by definition it is. I'm taking 99 and I'm multiplying it by 7. Who cares what it is? It's a multiple of 99. What about 63? Well, this 3 squared times 7, that right there, that's 63. So this number is 63 times 11. Is that a multiple of 11? Yeah, it's got to be. By definition, it is a multiple of 11. Are any of these numbers not used to get the 99 or the 63? No, there's no extraneous numbers here. There's no extraneous numbers. So this number is the least common multiple of 99 and 63. Okay, so just like before, to get the LCM, we just sort of chose the colors, right? So we said, okay, we need one orange one, one green one. Oh, we've already got this orange one, so we don't need to worry about it. But we still need this blue one. That's how we got 30. We're doing the same thing here, except now we're just doing it with symbols, right? Okay, let's see if we can find the GCF. So the GCF of 99, not 9, 99 and 63. Okay, so the GCF of 99 and 63. Let's see if we can figure that one out. So what we want is to find all of the prime factors that are common between these two. Okay, so let's see here. Do we have, okay, it looks like they both have a 3. How many 3s do they have in common? 2. Yeah, I see a peace sign over there. So we've got 3 2s. Do they have anything else in common? No, they do not. So we're done. That's it. So let's go ahead and actually multiply these numbers out. So let's see how we want to do this. What is it? 619? 693. I'm gonna just take your word for it. And this one here obviously is 9. And that's how we would go through with it. Let's quickly just go, remind ourselves how we would calculate that. So what I'm going to do, I'm going to just say that this is 99. So I've got, this is going to be 99 times 7. And you could just do it like that, right? The old-fashioned way. So 7 times 9 is 63. 7 times 9 again is 63. 63 plus 6 is 69. So 693. Okay, so that's how we do LCMs and GCFs using prime factorization. That's why we're sort of obsessed with this prime factorization. In the future, we're going to be looking at the LCM and GCF of things that are not just numbers. We're going to look at the LCM and GCF of what we call a monomial, okay, which is a slightly different thing. So that might be where we'll start learning about some stuff that you didn't do in grade 8, because it is expected that you've done some stuff like this in grade 8. So you can kind of think of this as kind of a bit of a review, but it's a review that's sort of leading us to something new, okay? So our task now is to complete the following 2 worksheets on Google Classroom. I'm hoping we can have this finished by Monday. So we've got this one here. It's prime factor explorations. So it basically looks at what happens when you multiply 2 numbers together. So kind of what we did right at the beginning here. And it also looks at what happens when we divide. So this is kind of just a question that you need to think about for yourself. And then the other one is greatest common factor and lowest common multiple. And again, it has some examples for you to work out. And then it'll ask you to make up your own example. I think that I added this one twice by accident. Okay, are we ready? Think we can do this? Yeah. What's up? You do not have to print it. No. Well, you can just write your answers on a piece of paper. If you wanted to print it, you can. But I mean, if you want, like, you can just sort of. You don't have ink. Okay, yeah, that's fine. You can just sort of draw this diagram yourself and do it that way. It doesn't have to be super detailed. What's important is that you're finding the multiples, right, and the factors. Okay. Any questions before we jump into this? No, we're good. Okay, I'm gonna end the video there. Bye bye.